So starting with a discussion of pop quiz 10, which was related to atomic physics and the space. And there was one part I added that was related to magnetism. Then the first question, figure 6.1 shows two bar magnets are there. On figure 6.1, sketch a pattern and the direction of a magnetic field line. So remember, the magnetic field lines are always pointing out from north and into south. So you have to draw arrow from north to south. In between, the line should be parallel because it's like a constant magnetic field, and around you can make curve. Even one line is enough because one mark is for showing the direction and one mark is for showing the pattern of the line. So even one is enough, but you can show that the magnetic field is pointing out from north and south. Then we have the next question. Explain why the moon is visible from Earth. Yeah, one line is enough for this because the distribution of the mark, minimum one arrow you have to draw from north to south, and not contradicting. Like example, it should not be curved because between the center, uh, the magnetic field line is constant. So if you just draw one arrow, that is fine. You will score the mark. If you draw only one arrow, but it should be parallel. Like if you're drawing two or three arrows, the lines between the poles should be parallel, shows a constant magnetic field, and around the pole, it will be curved. So one line is enough. Even you draw one line, you will score the mark. The next part is explain why the moon is visible from the earth. So what is the reason why moon is visible from the earth? Because the moon is actually reflecting the light of the sun. That's why it is visible. Moon is not giving out its own light. So example, if this is representing the moon, and here is the earth. So what actually happened? The sunlight strike the moon and then reflected to the earth. So what is the reason why the moon is visible from the earth, and it's of 2 marks? So how you score 2 marks? First, you will mention that moon is reflecting the light from the, like the moon surface is reflecting the light, or moon is reflecting the light. 1 mark is for mentioning moon or moon surface, and the second mark is for the light from sun. So moon is reflecting the light from the sun, or the surface of the moon is reflecting light from the sun. That's why the moon is visible. Then here we have to complete the cycle of the moon, the phases of the moon. As you can see on the 0 day, it's about like 28 days. One complete cycle is there. So some of the phases of the moon as seen. So it's like if we have 28 days, if we consider 28 days, about 28 days a cycle of the moon. So from 0 to like the from 1 to 7 days, it will be quarter of the moon. Then 7 to 14, it will be half of the moon. 14 to 21, it will be 3 by 4 of the moon will be visible. And then 21 to 28, full moon will be visible. Like when you're dividing it, say this is the position. We have the new moon is the no moon example. At this position, we have no moon. Then we will have the first quarter will be there. This will be the first quarter. Then we will have a full moon here at this point, like a 14. Then we will have the third quarter, and then we'll have again a new moon is there. So this will be in 7 days. This will be 14 days. This will be 21 and 28 days. It will be about like new moon will be there, or you can say we don't see a moon. That's a new moon. So we have to show the sites which will be visible. That will be different. Like after so this is a new moon, like this position. Then after 7 days, what we'll have like we'll be able to see half of the a moon, and the phase, because when it is at this position, different phase will be visible as compared to other side, like the side which is visible to us. So when we draw the circle, so here in 22 days, this part is visible. So 7 days, the other part will be visible to us. So this will be after 7 days. Then 14 days we'll have a full moon. Then we have a 3/4. And then after again 29 days, like they will have a new moon. And new moon means like we won't be able to see the moon. So it will be completely black. Is it clear, this one, the phases of the moon?
Yes, sir. Clear.
Then we have the next question, which is about state what the phases of the moon indicate about the motion of the moon. Like when we are looking at these phases of the moon, what it indicate about the, so we can say that moon is orbiting the earth, and duration of the moon orbit is about like 28 days, 29 days, you can say. So this give an idea that moon orbit the earth. With approximate duration for one complete revolution is 28 days, or you can say 29 days, 27 is acceptable as well. The average radius of the moon is given 3.84 exponent 5 kilometers. So example, this is a earth, and here this is representing a moon. So radius of the orbit is given. The previous question, mark distribution, 1 mark is for mentioning the moon is orbiting the earth, 1 mark is for mentioning the cycle of the moon, like how much time it takes to cycle or move to complete one revolution around the earth. So average radius is given, that is 3.84 into 10 to the power 5 kilometer. And the speed at which it is moving, the orbital speed is given, which is 1025 meter per second. We need time for one orbit. So how to work out the time for one orbit? So we have the formula: whenever object move in a circular path, that the speed at which the object move, that is given by the circumference 2 pi r divided by t. So if we need t, so that is equals to 2 pi r divided by v. So it will be 2 multiplied by pi, which is 3.14, multiplied by the distance, the radius. But one thing here, the speed is given in meter per second, but the radius is in kilometer. So you have to convert the kilometer into meter, because if the speed was in kilometer per second, then we don't have to, because distance and speed should be have the same base units in terms of like speed is, if speed is in meter per second, distance should be in meter. If speed is in kilometer per hour, then distance, if speed is in kilometer per hour, then distance should be in kilometer. So here the distance is in kilometer, but speed is in meter per second. So we have to multiply by 1000. So when we multiply by 1000, this will be 3.84 into 10 to the power 8 meter. So this will be 3.84 into 10 to the power 8, and that is divided by the speed, the orbital speed, which is 1025. So when we divide, it will give us 2.35 exponent 6 seconds. So 2.35 into 10 to the power 6 seconds, that's the one time for one orbit. So whenever object move in a circular path, you will always use this formula, that orbital speed is 2 pi r divided by t. Then the isotope of americium is shown here, and it is emitting out alpha. Whenever there's an alpha emission, the nucleon number decreases by 4, so this will become 237, and a proton number decreases by 2, so this will be 93. And for alpha, it is 4 and 2. Then figure 10.1 shows a diagram of a smoke detector. The smoke detector contains a sample of americium. This isotope ionizes the air between the metal plate. Describe how the americium ionizes the air, and it's of 3 marks. So how, if even a same question is there and they ask how the radiation can cause ionization, so the term ionization means like removing of electron from an atom or molecule. This will score 2 marks. 1 mark is for mentioning removing of electron. 1 mark is for mentioning atom from atom or molecule. And 1 mark is for mentioning the type of a radiation, like here alpha. So alpha particles from americium remove the electron from atoms, or you can say molecules, in air. So 1 mark is for removing electron, 1 mark is for mentioning atom or a molecule, and 1 mark is for mentioning that from where we get the alpha particle, we get the alpha particle from americium. As the americium 241 decay into, it gives out alpha particle. Then suggest 2 reasons why smoke detector use an isotope that emit alpha rather than gamma. One thing, because alpha is having the highest ionization, that is a, because so it can easily ionizes the air, that is 1 point. The second thing is alpha is a short range, so it cannot be harmful or dangerous for a person. Gamma is having a long range, so if a person is exposed to gamma radiation for a longer duration of a time, so it might develop a cancer. That's why. So 1 mark for mentioning alpha is having a greater ionization due to greater mass and charge. And the second is short range. So it is alpha is having a short range. So it is less harmful. So these are the 2 reasons why we are using alpha in the smoke detector rather than gamma. So this was a pop quiz related to atomic physics, space physics, as well as 1 part from magnetism.